So today for my lesson, I'm choosing the integral test, which I find the most interesting type of test to determine whether or not a series converges or diverges. So basically, I would start off with exactly what is the integral test. So I would say when we have a series a sub n where it starts at 1 and goes all the way to infinity, we're supposing that there's a positive integer n such that like n equals 1 is less than or equal to the value of n. And we have to know that if we're talking about a sub n equaling f sub n, we can then determine if f of x, it has to be positive, continuous, and decreasing based on the function x, okay? So then based on that, whether or not this integral converges or diverges, we can then determine whether or not the series converges or diverges. So I would show, first off, just a kind of recap of what we did before. So I would be talking about the p series test. So when we had like 1 over n raised to the p, if p is greater than 1, then that series converges, and then if it's less than or equal to 1, then it diverges, and that would come into play when we're talking about the integral test. So that's why I would look at it first. So basically from there, I would just be talking about like based upon this series, okay, if we were to do f of x is raised to the 1 over x to the p, we would first then plug it into the integral, okay, and basically from there it would be the integral of 1 over x to the p. Well, in order to find the antiderivative of that, we would have to basically I would say, okay, this is just a number, so it could be the integral as x to the negative p, and basically from there, to find the antiderivative, okay, you would basically just like subtract 1, okay, and then, or I'm sorry, add 1, and then divide by that. Okay, and so therefore the series converges. Okay, so then I would just go into something more in depth. So looking at this series now, the series as it approaches infinity of n e to the negative n squared. Basically what I would say to my students is I would say you need to replace, when you're talking about the integral test, you need to replace every m with an x and then plug it into the integral. Your bounds become whatever you're starting at, so n equals 1 would be your lower bound, and then your upper bound would be infinity, okay? So then from there, what I would do is I would actually say, since infinity is an indefinite term, you would then say, okay, let's say as the limit as b approaches infinity, I would replace that infinity with like a b, because that's hinting at the idea that it's still going towards infinity. So then from there, I would just basically say you're finding the antiderivative. In this case, you would have to use u substitution. So I would do u equals, I would do negative x squared, and then so du would be negative 2x dx. So then from there, you need to balance the equation, which means you need to put 1/2 out front. And then from there, you're plugging in your bounds. So you would plug in b and then subtract the lower bound of 1. And then from there, basically, you would just simplify and get 1 over 2 to the e, okay? Since this, I would explain, since this is a finite term, meaning it's not infinity, the integral converges, and therefore the series also converges. So I would just go through a couple more examples with that, but then what I would tell my students is that the integral test does not say that the series converges at the same value as the integral. It has to be determined whether or not the series converges to some number. So the problem of computing the value of the series is generally also much harder. Okay, so here's a couple of practice problems that I would instruct my students to do. So I would just start with number 1, basically saying, okay, if we're using the integral test, okay, you would want to determine whether or not the series converges or diverges. So what I would do is I would replace, I'm going to go down here to do my work, that m with an x, and my I would basically be finding the limit as b approaches infinity. Okay, I would say you can jump to this step from 1 to b, and then it would be 1 over, I would replace, this would be at 1/5 because it's the 5th root, like up there. Okay. So then from there, basically you're just finding the antiderivative of that. So this would be the limit as b approaches infinity of, I would move that exponent to the top, so it would be x to the 1/5. So then from there you would add 1 and then divide by that. This would be 4/5, but when I divide by 4/5, it would be just multiply by 5/4. So then it would be x to the 4/5 and 5/4 out front as the limit b approaches infinity. Evaluate from 1 to b. Okay. So then from there, it would be the limit as b approaches infinity, and then I would just basically plug in the bounds. So it would be 5/4 b to the 4/5, okay, minus 5/4, and then 1 to the 4/5. This is just 1 over here. But then if I plug in infinity over there, well, it's really, you're raising infinity to the 4th. Infinity, anything raised is just still going to be infinity. So this over here would be infinity, which means that infinity minus 1 is just infinity. So therefore, it's diverging because it's not a finite term. Okay, so that would be the simplest one I would do. Okay, a couple other problems that we could do together would be something like, I'm just trying to look, something like 11. Okay, so in other words, here's what I would do. Replace every x or every m with an x and then do the integral. So you could do the limit as b approaches infinity. Evaluate it from now 2, because it's the lower limit, is that, to infinity. Okay, and then it will be 1 over x to the ln of x squared. Okay. So once again, and then dx, of course. Once again, we would have to use u substitution. So I would say, okay, I see a 1 over x. Okay, so I could use u is the natural log of x, and then du would give me that 1 over x dx. Okay. So then from there, it would be the limit as b approaches infinity. Okay, from 2 to infinity. Okay. And so it would, this 1 over x dx would turn into just du. And so you would just get 1 over u and then squared because of this one. Okay. Keep moving along. You would have the limit as b approaches infinity. Okay. And then I would move that exponent to the top, so it becomes -2 du. Then just add 1 and divide by that, you would get -1. So I'm just going to do a couple steps in one. This would be the limit as b approaches infinity. It would be a -1 over u, but we remember u is natural log of x. So it would be natural log of x here. And then evaluate it from 2 to infinity. Okay. So then from there, just plug in, or sorry, this should be b. Okay. Plug in your bounds and then take the limits. Okay. So it would be -1 over natural log of b. And then from there, minus a -1, so it'd be really plus 1 over natural log of 2. This is just a finite term, but what I'm really concerned about is if I plug in infinity there, it'd be 1 over infinity. Okay, but then from there, 1 over infinity is just, it's getting a really large number on the bottom, so that would just be 0 plus 1 over natural log of 2, which is just 1 over natural log of 2. And in other words, that would be a finite number, so since the integral test converges, then the series therefore converges as well. Yeah, so I would just basically tell my students, I would maybe do a couple more problems in the time we had in class, but for homework, I would say to my students, try the following problems, 4, 9, and 14, because those are similar to what we just did. And so basically, I would conclude this lesson by saying the integral test is a way that you can integrate what you learned in Calc 1 based upon how to find it, or how to find an antiderivative, and how it can determine whether or not a series converges or diverges. And that would be my lesson for today. Thanks.